Assalamu alaikum. Myself Dr. Ansari Farzana Zama, Department of Chemistry, J.A.T.rts Science and Commerce College for Women, Malegaon. Welcome all of you. Today we are going to continue the column chromatography, adsorption column preparation and loading. The column used for adsorption chromatography must be uniformly packed with the adsorbent material. Uneven packing of material may lead to the formation of cracks and channels in the column, resulting into distortion and shifting of adsorption band. If the particle size of the adsorbent material is not uniform, it should be shifted before remove use to remove larger particle. Fine particles should be removed from adsorbent using sedimentation process. In the sedimentation procedure, the silica or alumina is stirred into between 5 to 10 times its volume of the selected solvent or the solvent system and is allowed to settle for few minutes. The supernatant liquid is decanted off and the procedure is repeated until the supernatant liquid is clear. The amount of adsorbent used should be approximately 25 to 50 times the weight of material to be separated. A slurry of adsorbent material in the solvent 1:10 is poured through the funnel into the clean dry column, clamped vertically away from warm air current, oven, etc. Gentle tapping of tube is done with the help of wooden rod to ensure even setting of the adsorbent without any air bubbles. Fresh solvent is allowed to flow through the column and it is ensured that the level of the solvent never falls below the level of adsorbent. The top of the column is covered with circular filter paper or a layer of sand to avoid disturbance of the surface during loading of the sample. A concentrated solution of mixture to be separated is loaded into the column through the pipette and the separation of different components is achieved by using suitable eluting solvent. Now, application of conventional column adsorption chromatography. First application is purification of anthracene. 50 mg of anthracene is dissolved in 50 ml of hexane with warming if necessary. A 20 cm column of activated alumina is prepared using a slurry containing 50 g of activated alumina in hexane. The column is glass chromatography column of 1.8 cm diameter and 40 cm length, fitted with sintered disc adapter with the tap and separatory funnel. The anthracene solution is poured on the top of the column from separatory funnel. The funnel is rinsed with the little hexane and then the chromatogram is allowed to develop with 200 ml of hexane. The column is examined from time to time in the light of an ultraviolet lamp. A narrow deep fluorescent zone due to carbazole will be observed near the top of the column. A yellow colored non-fluorescent zone due to napthacene will be seen next down the column. The intensity of this zone will be depends on the purity of sample of anthracene used. A blue-violet fluorescent broad zone due to anthracene is obtained in the lower part of the column. The development of chromatogram is continued until the anthracene begins to eluate from the column. The first few portions are rejected since they might contain the less strongly adsorbed paraffin like impurity. The elution is then continued with hexane and anthracene, and eluate is collected in a clean receiver. It is ensured that the yellow colored zone does not reach to the bottom of the column. The eluate fraction containing anthracene is concentrated under reduced pressure using rotary evaporator to about 2 ml, cooled in an ice salt bath and by means of ice cooled hexane transferred through a funnel into another clean flask. The pure anthracene crystals are washed with ice cold hexane and the fluorescent product having a melting point of 215 to 216 degrees C is obtained. Size exclusion chromatography. Size exclusion chromatography, also referred as gel chromatography, is a powerful technique that is particularly used for separation of large molecular mass species. The packing material used as the stationary phase for size exclusion chromatography consists of porous material like 5 to 10 silica particle or polymer particle containing a network of uniform pores. The solute and solvent molecule can easily diffuse through the pore. The fractionation of molecule depends on their size and also to some extent on their shape. It should be noted that size exclusion chromatography is different from the other type of chromatography as there are no physical or chemical interaction between the analyte and stationary phase. In fact, such interactions are avoided as they lead to lower separation efficiencies. Dextrane, Cefadex, agarose, or polyacrylamide are the commonly used polymer as packing material in size exclusion chromatography. The exclusion limit in the molecular weight of that molecule that will permeate the gel stationary phase molecule pore and can be retarded. This can range from molecular weight of 1000 to several million. Some application of size exclusion chromatography are: it is mainly used for separation of protein. It is also used to obtain the molecular weight distribution of polymer. It is used in separation of enzyme, peptide, nucleic acid, hormones, and polysaccharides. It is used to examine the stability and characteristic of natural organic matter in water. Thank you for watching.